Hey y'all, today is March 14th and this is your little mini lesson on outcomes and events. Let's get started. Nora must create a 4-character password to log into a website. The password must have 3 letters followed by a single digit 0 to 9. She decided to use her initials as the 3 letters and then randomly select the digit. So number 1, list all possible outcomes for choosing a digit. So it tells us in here that it's going to be from 0 to 9. So we're going to list all of those numbers in order. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are all of the possible outcomes for choosing a digit. Okay. Number 2, list all outcomes for choosing a number that is greater than 4. Okay, so greater than 4 means that 4 is not included. So we're looking at the numbers that are bigger than 4. So 5, 6, 7, 8, and 9. So 5, 6, 7, 8, and 9. Okay. Now number 3, list all outcomes for choosing a number that is at most 7. So at most 7. So that means that 7 is included. So it is 7 and all of these numbers that are smaller than 7. So 0, 1, 2, 3, 4, 5, 6, and 7. So 0, 1, 2, 3, 4, 5, 6, and 7. Okay? So that's it for that first little section. Let's look at number 4. It says the spinner is spun once. List the possible outcomes. Well, we've got 16 sections on this spinner. So our outcomes are 1 through 16, and I'm going to list them all out. So 1, 2, 3, 4, 5, 6, 7, 8. And then just to save room, 9, 10, 11, 12, 13, 14, 15, and 16. So all sections of the spinner are listed there. Now, list the favorable outcomes for A, spinning an odd number. Well, all of the numbers that are odd. So 1, 3, 5, 7, 9, 11, 13, 15, and that's it because it stops at 16. So just 1, 3, 5, 7, 9, 11, 13, and 15. Now B says spinning a number less than 6. So less than 6 means that 6 is not included. So that's 1, 2, 3, 4, and 5. Okay. C, spinning a number that is at most 9. Well, at most 9 means that 9 is included, and it's all the numbers smaller than and up to 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, now for D, spinning a perfect square. We talked about perfect squares in our notes in class today, but the way I find a perfect square is I multiply the same number together. So for example, 1 times 1 equals 1. That means that 1 is a perfect square. 2 times 2 equals 4. That means 4 is a perfect square. 3 times 3 equals 9. That means that 9 is a perfect square. And 4 times 4 equals 16. That means 16 is a perfect square. So in my spinner, the perfect squares that I have are 1, 4, 9, and 16. And y'all, I'm really sorry about all this extra noise caused by my 6th period class. So 1, 4, 9, and 16 are the perfect squares. E, spinning a prime number. Now we talked about prime numbers in our notes in class today. The way I find a prime number is it's a number that can only be made by multiplying 1 and itself. So let's look at our spinner. And it has to be a number bigger than 1. So I'm not even considering 1 here. Now 2, how do I make 2? I multiply 1 times 2 together. That's the only way I can make 2, so I know that 2 is prime. Okay, how do I make 3? Well, I multiply 1 times 3. And that's the only way I can make 3. So I know that 3 is prime. How do I make 4? Well, I can multiply 1 times 4, but I can also multiply 2 times 2. So because I can multiply 2 times 2 together, I know that 4 is not prime. Let's look at 5. I can multiply 1 times 5 together. Any other ways I can make 5? Nope. So I know that 5 is prime. 6. I can multiply 1 times 6, 2 times 3. Because I can multiply 2 times 3 to make 6, I know that 6 is not prime. 7. I can multiply 1 times 7. That looks like 1.7, sorry. 1 times 7. Can I multiply any other whole numbers together to make 7? Nope. So that means that 7 is prime. 8. How do I make 8? 1 times 8, 2 times 4. Because I can multiply 2 times 4 to make 8, 8 is not prime. How do I make 9? Well, 1 times 9, 3 times 3. Because I can multiply 3 times 3 together to make 9, I know that 9 is not prime. 10. We have 1 times 10 and 2 times 5. Because I can multiply 2 times 5 together to make 10, 10 is not prime. 11. 1 times 11. Anything else? Any other whole numbers that I can multiply together to make 11? Nope. That means that 11 is prime. 12. We've got 1 times 12, that makes 12. I've got 2 times 6 and 3 times 4. Because of 2 times 6 and 3 times 4, I know that 12 is not prime. 13. I've got 1 times 13. Can I multiply any other whole numbers together to make 13? Nope. Because of that, I know that 13 is prime. 14. 1 times 14 and 2 times 7. Because I can multiply 2 times 7 together, I know that 14 is not prime. 15. 1 times 15. 3 times 5. Because I can multiply 3 times 5 to make 15, 15 is not prime. 16. 1 times 16. 2 times 8. 4 times 4. Because I can multiply 2 times 8 and 4 times 4 to make 16, I know that 16 is not prime. So my prime numbers are these ones that I've listed with a P: 2, 3, 5, 7, 11, and 13. So 2, 3, 5, 7, 11, and 13 are the prime numbers here. Okay, let's move on to our next section here. So, a bucket contains the letters shown below. Each letter also has a point value. If one is chosen at random, give the number of favorable outcomes for each event. So our instructions here change. Give the number of favorable outcomes for each event. We're not listing the outcomes anymore. We're telling how many favorable outcomes there are. So number 6, choosing a vowel. Well, vowels we need to understand are A, E, I, O, and U. We're not going to count Y, which is sometimes considered a vowel. We're not getting into sometimes, okay? So, what of those letters are here? Well, I see an A. Is there an E? No E. There's an I. There's an O. And I don't see a U. So how many vowels are there? Well, there are 3. Oops, let's change that color back. 3. Okay, let's erase that. Now, choosing a tile worth at least 3 points. So that's key, at least 3 points. So that means greater than or equal to 3 points. So 3 is included. And I know that this is hard to see, but this B is worth 3 points. So that one counts. Okay, D is worth 2 points. That one does not count. F is worth 4 points. That one counts. L is worth 1 point. That one doesn't count. I is worth 1 point. That one doesn't count. K is worth 5 points. That one does count. A, O, and T on the bottom are all worth 1 point, so they don't count. So how many are worth 3 or more points? 3 tiles. Okay. Last one, choosing a tile or choosing a letter in the word bankrupt. And I just couldn't think of a nicer word than that. So that's the word we ended up with, but bankrupt. So are there any B's? Yep, there's a B right there. What about A's? Yep, I've got an A. N. Do I have any N's? I don't have an N. I do have a K. Do I have an R? Nope. Do I have a U? I do not have a U. Do I have a P? No P's. I do have a T. So I've got 4 letters that are in the word bankrupt. Okay? So let's move on to our next section. A pencil box contains 5 red, 6 yellow, 8 blue, 3 orange, and 2 purple colored pencils. 1 pencil is chosen at random. Well, how many possible outcomes are there? So let's see, what color do I want? Okay. How many possible outcomes are there? I'm just going to add them up. 5 plus 6 plus 8 plus 3 plus 2. When I add that all up, I get 24. So 24 possible outcomes. Now, give the number of favorable outcomes for choosing yellow. Well, there are 6 yellows, so 6. Give the number of favorable outcomes for choosing blue or purple. Well, there are 8 blue and 2 purple. So 8 plus 2 is 10. There are 10 possible outcomes for that. Okay? Now, give the number of favorable outcomes for choosing red and blue. This key word here, and. Well, if we're choosing 1 pencil, can I pick out a red and a blue? No, I can't pick out both colors at one time. So there are 0 favorable outcomes for that scenario. And you might want to make a note. You cannot choose 2 colors at once. Okay, and last one, number 13, give the number of favorable outcomes for not choosing orange. Well, there are 3 orange out of the 24 colored pencils. So for not choosing orange would be anything but those 3. So I'm going to say 24 minus 3, which is 21. So there are 21 favorable outcomes for not choosing orange. So that is the end of our lesson today. Y'all have a great day.